Hello everyone and welcome to my channel. My name is Johan, is also known as Virus, and this is going to be the second part of the AWS Cloud Quest Cloud Practitioner um, video game, if you want to call it. The first part was a live stream on YouTube, which I will put down in the description below, and I will go through the second part now. Second part I call it, so of course there's no parts in the game, it's just a full game. It's just that I'm, due to time limitations, I'm making it into parts. Right, so let's continue. Last time we covered we did two quests. Oh yeah, I forgot a pet. It's in Cloud.io. We covered we had two tasks, jobs, missions, things. Need to remember how they're called. And we also hit some drones, like this one. Oh, what's with that? Ah, okay, I see. There's a distortion. Oh, no, I think let's go do some. Or should we build this? Why not? Let's build this. I did say that I'm gonna put a tree like that. My wife loves trees like that. What else? So yeah, as I was saying, we did on the first part. We did two missions. One was for to create a static website using Amazon AWS S3, and then we had to also create to spin up two Amazon EC2 instances for reliability. Then we also hit some drones. The drones, when you do, you can access them. I'll show you again. So let's go back here. To drones, you can hit them by pressing this button that says Zap Drones, and the drones, what they basically give you is a quiz on. Come on. I just figured out that if you haven't started the mouse on a very convenient point, it's not very easy. So it's better to just move to a different position and do it again. What I wanted also to say was that I will be not cropping these videos as it's a walkthrough, and maybe somebody where's the dog? Come on, my pet friends. Whoop, let's walk him. There he is. Radar. Hey, Radar. Let's see where we have some roles, some computing solutions. Oh. Okay. Taking us directly. Okay, let's go for the third one then. Hello. Yeah, as I was saying before I enter the mission, I will not be cropping down the videos because the walkthroughs, I know that it's not going to be interesting as a video going to show us big on YouTube, but for whoever wants to see all the quizzes and all the missions, I think it might be better. In any case, I'll try to make them short, like 20 or 30 minute sessions, so they're not look as long and as perhaps boring. But in that case, there are going to be more parts. Okay, let's go for the next mission. Welcome to our state-of-the-art school. Thanks for coming to help us. Okay, let's see. What do we get out of that? 50 gems, 3 options, 10 Amazon EC2 points. Okay, no problem. It seems you need help with your class schedules. Yes, we're currently running a class scheduling algorithm, but our Amazon EC2 processor has been running out of computing power and memory. This affects other tasks running on our application, which impacts the classroom and study room scheduling system. I think we can quickly provide a more balanced solution between compute and memory by upgrading your EC2 instance. Is your scheduler complex? Oh, it's pretty simple for now. We might add some more advanced features in the future. That's fine. If your algorithm becomes increasingly complex, we have high-performance computing technologies that you can use to get the most out of your instances. What kind of features are you thinking of? The features would mostly relate to course selection. We've explored a front-end feature that students can use to book classes from home. Okay, great. I was thinking of some more advanced features for data processing. But in this case, changing your current system's instance type should be fine. Sounds great. If we ever want higher performance features, I'll make sure to contact you. Okay, are you ready to help us upgrade our system? So objective is to change the Amazon EC2 instance to a larger instance type. Let's go. Accept. And start. Right. Computing solutions. Okay, this solution you can connect to your Amazon EC2 instance in multiple ways, such as using EC2 Instance Connect from the AWS Management Console. So, let's see what they have. They have a T2 Micro, and basically what it shows here is how we can connect to the terminal with an SSH through Instance Connect through the AWS console and through a browser through HTTP 80. This is how the browsers access the server. Okay, let's go ahead. As I might have mentioned, I'm just learning now, so for some things, please bear with me, if I may say so. For example, CTH AWS Systems Manager, I cannot really remember what that is, but I'm more than excited to find out. Anyway, the overall goal is to upgrade to an M4 large instance. So let's see. Step 2. You can also connect to your EC2 instance by using Session Manager, a capability of AWS Systems Manager. Okay. You can configure the instance metadata service and specify commands in the user data field to run after the instance launches. This way you can view metadata details in a web browser. Okay. EC2 instances are also accessible through SSH clients by using terminal software on your local device. To meet a greater compute performance need, you can change the EC2 instance size to larger instance type. Okay, let's go to plan. Practice goals. Explore Amazon EC2 instance types. Filter EC2 instances based on their attributes. Connect to an EC2 instance using Amazon EC2 Instance Connect. View EC2 instance metadata using the instance public IP address. Start and stop an EC2 instance by using the Amazon EC2 console. DIY goals build on what you have learned. Change the Amazon EC2 instance type to a larger general purpose instance. Okay, let's check. Step 1. Review the practice lab objectives. Yes, we did that. Your concept section below, click Start Lab to provision your environment, and then click Open the AWS console to begin. Follow the lab instructions carefully and use the arrows below to navigate between steps. Yeah, okay. In this practice lab, it's basically what we read earlier in the plan part. Okay, let's go ahead and start lab. Starting. Step 2. On the top navigation bar, review the region selector to ensure that the region is set to North Virginia, US East 1. In the services search box, type EC2. Okay, we'll wait for the environment. Okay, and it's ready. The lab is ready. Let's go. Open it up. So we need to check first that it's US North Virginia, US East 1. Okay, that's good. There's 3 in the search results under services. Click EC2. Okay. Let's go for EC2 then. Although we already have it here, let's go with the steps. Why not? Let's go back. In the left navigation pane, click Instances. Go to the next step. Oh, okay, right. That makes sense. If the scenario says that there is one running, yeah, there should be one running. In the instances section, choose the checkbox to select the AWS Computing Solutions instance. Click the Details tab, review the details, go to next step. So, click it, Details. Okay, let's see where this goes. In the left navigation pane, click Instance Types. Go to the next step. What's that? Instance Types. Alright. Nothing appears. Yeah. Wise. Amazon EC2 provides a wide selection of instance types that belong to instance families that are optimized to fit different use cases. Right, in the instance type section in the filter box, type the following and press enter after each. T3 large. Oh, okay, they appeared. Finally, they loaded. T3 large. Okay. And then C5 large. C5 large. And R5 large. There you go. Let's select all of them. So this is okay. For each instance type, review the instance details. Oh, okay. I see. That's handful. That's useful. You can compare them. To compare compute, networking, storage, accelerator, and pricing information, scroll down. In the left navigation pane, click Instances. Go to next step. Right. So, hypervisor, Nitro. Let's see where we see the most differences. In T3 large, I see that burstable performance support is true, okay? Whereas for the other ones, it isn't. What's the other great difference? I see that sustained clock speed gigahertz. So for the it's a one core CPU, virtual CPU, and then where it starts getting different between the three. So obviously CPU. I mean, with C5 large having the biggest, and then with R5 large having the biggest RAM. And then T3 large having more IP version 4 and 6 addresses per interface compared to the other two types, but the network speed is half. It's up to 5 gigabits, gigs compared to C5 and R5 large. And then supported placement group strategies, cluster partition spread, cluster. So, and then similarly, the T3 large lacks cluster, whereas R5 and C5 large have cluster partition spread for group strategies. Okay. Pricing. From the three, R5 seems to be the most expensive, both Linux and Windows. I think. Actually, yeah, it is most expensive than all of them, than the three of them. Okay, let's go to the next one. So I should click on instances. And then next, choose the checkbox to select the AWS Computing Solutions instance. It is checked. On the Details tab under Public IP version 4 address, click the copy icon to copy the provided address. We're copying it. Should we open it? and yeah, we should check it on a new tab as expected. Open a new browser tab and then paste the IP address that you just copied and press enter. Review the instance details and then return to the previous browser. Okay, and there it is. T2 micro AWS East 1A instance family T2. Right. Next, the instance sections. Click. Let me close that. Click connect. Okay. Connect. Then the EC2 Instance Connect tab, review the connection settings. Click the Session Manager tab. Okay. Session Manager usage. Connect to your instance without SSH keys or a Bastion host. Sessions are secured using an AWS key management service key. You can log session commands and details in an Amazon S3 bucket or CloudWatch. Logs, log group. Configure sessions on the Session Manager preferences page. Okay. Review the Session Manager usage details. Click the SSH client tab. Concept. Using Session Manager, you can manage your EC2 instances through an interactive one-click browser-based shell or through the AWS command line interface, AWS CLI. After the session begins, you can run bash commands as you would through any other connection type. Fine, SSH client, okay. Review the requirements for connecting through SSH. Note that a key pair is required. Click the EC2 Instance Connect tab. Let's go back to that. You can connect to your instance by using an SSH client on your local device to your instance key pair. Your device might have an SSH client by default, or you might need to install an SSH client. Click connect and then wait for the terminal window to open and go to the next step. The EC2 Instance Connect API pushes a one-time use SSH public key to the instance metadata for 60 seconds. An IAM policy authorizes your IAM user to push the public key to the instance metadata. The SSH daemon on the instance uses the authorized keys command. Authorized keys command user to access the public key from the metadata to authenticate and connect you to the instance. Okay, let's give it a try. Connect. Okay, establishing connection. Okay. And we're in. I think. Yeah, have a cursor. Interesting. Let's go next. To change the application directory in the command prompt, run the command type and press enter. Okay, yeah. Right. That's a bit, in my opinion, a bit counterintuitive. I mean, okay, now we're following steps, but as a normal administrator, you would, if you didn't know how the app is called, file, the folder, the directory of the app, you would still do an ls, in my opinion. So let's see, ls. Okay, we have sample app, so say cd sample app. If you do tab, it does work. We're in sample app. To autofill, sorry, wrong tab. To check the instance log, run tail space. Does it do copy paste? No, it doesn't, obviously. Oh, it's LF. I thought it was 1. Oh no, it is 1 because L is differently written. So tail space dash 1F. That was the rest. AWS Compute Solutions.log. Actually, what I could have done. Yeah. Okay, we'll use the tab. What I want to do is that. Actually, let's just do it. I want to do ls to see, obviously, the contents of the directory, and then tail space dash 1F AWS space log. Right. To close the terminal tab to return to the instances page in the Amazon EC2 console. Checked. Okay. after you're connected to the instance, you can control the instance by using AWS CLI commands. The command prompt behaves as if you are connected locally. So to say close it. Let's go to the next step. Click actions to expand the drop-down menu. Choose instance settings. Choose edit user data. Okay. Instances. Right. Select it. Instance actions. Sorry. Instance settings. Edit user data. Under current user data review the commands, click cancel, go to the next step. Bin bash. Sudo. So right, what it does is it updates everything, then installs Python 3. Okay, makes sense. Right, cancel. In the left navigation pane, click instances and then stop instance. Instance state expand menu and then stop instance. Okay. Instance state stop instance. Stop instance. To confirm that you want to stop the instance, choose the stop button. Stop button below. Okay, it's done. Using the instance state drop-down menu, you can place an instance into different states of activity. You can start and stop an instance if it has an Amazon Elastic Block Store volume as its root device. In the pop-up box, click stop. Yeah, we did that. Go to the next step. After an instance stops, CPU usage and data transfer charges cease, but storage charges for any attached Amazon AWS volumes continue. On the Details tab, after the instance state changes to stopped, review the public IP version for address and DNS. Okay. There's the address, there's the DNS. They should both be empty. Huh? Do I need to refresh? Let's refresh. Looks like a refresh. And indeed, public IP version for address and DNS are empty. Right. Go to the next step. Each time you start a stopped instance, AWS charges a minimum of 1 minute for the use of per second billing instance. After 1 minute, AWS charges only for the seconds that you use. Right. Next. Click actions to expand the drop-down menu. Choose instance settings. Review the available options. You have different options to change your instance, such as type, termination protection, and shutdown behavior. Oh, okay, indeed. Go to the next step. You must stop your Amazon EBS backed instance before you can change its instance type. Plan for downtime while your instance is stopped. Stopping the instance and changing its instance type might take a few minutes, and restarting your instance might take a variable amount of time depending on your applications. Startup scripts. Okay. Fine, as you wish. Actions. Instance settings. Right. I'm pretty sure it's going to ask us to change the instance type, or that might be in the DIY. Click instance state to expand the drop-down menu. Choose start instance. Go to the next step. Okay. Okay. That will be indeed start instance. Okay. Starting. Successfully started. Pending. Instance state pending. Go to the next step. Okay. After the instance reaches the running state, review the instance details, not the public IP version for address and DNS and OP related. Go to the next step. Running. No public, but let's. What happened here? Other notifications. What would that be? Okay. let's go back to fully to work, back works. And if we click it, I was going to refresh it, but anyway, it's the same result. We do have now a public IP version for address and DNS. Congratulations, you have completed the practice section. Go to the DIY section to complete the solution. Right, so pretty much DIY activities, change the Amazon EC2 instance type to a larger M4 large general purpose instance. Instance ID. Okay, so let's go over here. Stop it. Stop instance. Stop. Stopping. Stopping. Stopped. Okay, so let's go to instance state. No, sorry, actions. Instance settings and change instance type. So I suppose this is where we need to go down to the drop down M4 tab large. Wait a minute. M4 large. Apply, and that should be it. Instance ID, let's copy it. Or we can copy it from here. Go here, paste it, validate. You did it, we found the EC2 instance type and for large. Now return to the city and give your customer the good news. Exit. Hello, he is happy. Wow, our scheduler is running great now. Our school is running like a well-oiled machine. I'm glad to be of service. Here's your reward. Oh, so we get the school, but what do we put? Right. Option 1. Some benches. So what do we get? We get basically a basketball court. Looks like, yeah. That cannot tell if it's. We get some sand. Or those horses, like medieval Alsace kind of thing. With the continue with the castle theme from the castle that we got as a house from the first part. If you remember, if you don't, go check it out. I just realized I have the pretty much same clothes with this guy and I don't like it at all. I should go change my clothes at some point whenever that is doable. I think I would like more buildings like this one. Not completely sure if I like the fact that they're parallel or has more green. Let's go with this one, why not? They're both as leveled up. Clear level is to 4. Thank you very much. New builder level. Your builder level increased to 3. Hey, how would you rate computing solutions? Not bad actually. I suppose the next one is that lady over there. I'm not so sure. Let's go. Cloud economics, networking concepts. I would definitely go with networking concepts first and the economics of it. Let's see. Oh, Radar is here. Welcome to our banking headquarters. I'm so glad you came to help. Amazon EC2, Amazon VPC. Starts getting interesting. I would need at some point for one of the droids that I had, drones, sorry, not droids, to DynamoDB, I think, card. Well, the idea is those points that you get some sort of cards, like flashcards that you can use for some interactive quizzes with the drones. Anyway, let's go ahead with this one. I'm always happy to help. What can I do for you? Right. We recently migrated our services to the cloud, but we've noticed some connectivity issues with our Amazon EC2 instances and databases. Our EC2 instances cannot connect to the internet, and our databases are unable to communicate with our instances. Okay, so we need to put them in the same VPC or something. Have you checked your virtual private cloud or VPC settings? In your root tables, you can check that an internet gateway is attached and that the VPC is set to allow outside traffic. Is that complicated? I'm a little concerned. We need those changes to happen immediately. We can't afford to wait too long for network updates. I understand your concern. Security group and root table modifications are applied immediately. Also, setting up an internet gateway for internet access can be done in minutes. That's great, but how did my engineers create a VPC without internet access? Isn't that included? No. In AWS, by default, VPCs are configured with internet gateways and routing to the internet. When you create a new VPC, you can choose whether all or part of the VPC should be exposed to the internet. This way, you can customize your own network security configuration to meet your requirements. So, we need to configure the routing table and attach an internet gateway to the VPC, and then also configure the security group. Interesting. I will check with our engineers later. It would be great if you can solve these connectivity issues. Will you help us solve our VPC connectivity issues? Yes, of course, ma'am. I will. Perfect. Thanks for assisting with our network issue. Okay, let's go ahead. This solution uses a common network architectural configuration that allows only internet traffic to reach publicly exposed AWS resources. So we have the internet gateway router. Right. So this is the VPC, this is the web server that the lady was talking about, and the DB server, the two different EC2 instances. These are their internal VPC addresses. Let's go ahead. The web server and DB database server are deployed within a virtual private cloud VPC, which is a logically isolated virtual network. The web server is deployed inside a publicly exposed subnet and is assigned a public IP address to make it accessible from the internet. Okay. Then why? I think the internet gateway is not. Let's see. The security group for the web server is configured to allow access through port 80, the default port for HTTP connections. A root table is configured within the VPC that allows internet traffic through an internet gateway to the public subnet only. The DB server, the database server, is protected and is only accessible from the subnet in which the web server resides. The database server resides in a private subnet which does not have a root table that allows access from the internet. Right. So, let's go through it one more time. What is happening here is, you see that our infrastructure, right? The web server where the application runs, the database server where the database for the web server is. They're in the same VPC. So the web server is deployed inside a publicly exposed subnet, so it's in a subnet of the VPC that does get exposed to the internet and has a public IP address to make it accessible from the internet. On the other hand, the server, the database server, is not, so that it remains within the company. Okay, root table is configured within the VPC that allows internet traffic through an internet gateway to the public subnet only. The database server is protected and is only accessible from the subnet in which is the web server. So it is in a separate subnet, but it has, through the routing table, access only from the subnet on which the web server is. Okay, let's go. Yeah, and as I was saying, the database server resides in a private subnet which does not have a root table that allows access from the internet, only access from the web server. Okay, let's go next to plan. Practice lab goals. Let's see what is needed from us here. Explore the components that comprise a virtual private cloud. Configure a root table attached to a subnet within a VPC. Okay, so that. Configure the root table attached to this public subnet. Configure an internet gateway inside a VPC. Configure inbound rules within the security group to control access. DIY goals: change the security group rules to allow traffic over port 3306 into the database server. Okay, let's see. Practice. Let's close that. We provided, yeah, okay. Let's start the lab again. We know how the drill goes now. While waiting for the lab, for the environment to boot up, let's see what we need. So EC2. Okay, so the usual stuff. Let's check where what the region has been selected is. Come on, lab. Come on. Starting. How about we go through a few of the steps? In the left navigation pane, click Instances, okay. In the Instances section, choose a checkbox to select the web server instance. Okay. On the Details tab under Public IP version 4 address, click the copy icon, copy the provided address. Okay, fine. In your web browser, paste the IP address that you just copied and press enter. After a few minutes, a site timeout message will appear. To solve this issue, return to the previous browser, the Instances page in the Amazon EC2 console. In the Instances section, choose the web checkbox to select the web server instance. Click the Networking tab, review the public and private IP version 4 addresses, go to the next step. Using Amazon Virtual Private Cloud, you can launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you would operate in your own data center, with the benefits of using the scalable infrastructure of AWS. As your subnet ID, click the provided ID. Go to the next step. A subnet is a range of IP addresses in your VPC. You can launch AWS resources into a specified subnet. Each subnet must reside entirely within one availability zone and cannot span zones. What is happening to our lab? I'm wondering. Usually it doesn't take that long. Might need to exit and start it again. In the subnet section, choose the checkbox to select the network concepts. Okay, there it is. Let's open it up. There it is. It's booting up. Right. Let's go for EC2 and instances. Hello. This is our web server. This is the public IP version 4 address. Let's try and open it. It says normally it should time out. Okay, and indeed, timed out. This site can't be reached. Right, so we need to go to networking, checking the public and private IP version 4 addresses, right? the subnet ID, it says. Subnet ID, click it, then so we're in the subnet. In the subnet section, choose this checkbox, select the network concepts subnet, right? And then click the root table tab. Next to root table, click the link name that contains web server subnet 1. We do click it, and what happened? Root tables, details, okay. Root table contains a set of rules called routes that are used to determine where network traffic from your subnet or gateway is directed. Use a public subnet for internet connected resources and a private subnet for resources not connected to the internet. Okay, seems fair, seems easy enough. Public access from the internet, private internal to the resources. In the root tables section, choose checkbox, select the network concepts. Okay, we're supposed to go back. No, root tables. Right, here we are. Click Routes tab. Click Review the table. Entries 1 route sends local traffic to the local network only. And the other route sends all other traffic to the internet through a NAT gateway. Click the Edit Routes. Go to the next step. The CIDR naming convention 0.0.0.0/0 represents all IP version 4 addresses. :/0 for IP version 6. Okay. So far so good. So edit routes. Let's see what we need to do. To delete the NAT gateway from WABA. Are we supposed to select it? No. To delete the NAT gateway from the root table, click remove. Oh, okay. I see. Remove over here. NAT gateway is a network address translation service with the NAT gateway instances, and a private subnet can connect to services outside your VPC. External services cannot initiate a connection with those instances. Sure it's gone. Oh, and it was removed. Okay, just like that. Click Add Route. Yep. Oh, wait a minute. Okay. Add. Configure the new route for destination. Type 000. 0.0.0.0 /0, I think. Oh, sorry, 0 I meant. Yep. For target, choose Internet Gateway, and then type IGW, like that. Choose the network concepts VPC, click Save Changes. Creating, okay. Updated routes, okay. Click Save Changes, go to the next step. An Internet Gateway serves two purposes. Provide a target in your VPC route tables for Internet routable traffic. Perform network address translation for instances that have been assigned public IP version 4 addresses. The root tab, preview the Renew Internet Gateway Association. Subnet is now reachable from the internet. Navigate to the instances page on the Amazon EC2 console. Remember, on the top navigation bar, you can use the services search box or click services to navigate to a different service console. Okay. Let's go back to and if we go to the EC2 global view, what do we get? Yeah, indeed. Don't tell me it's gonna show. Right, not for us. How about we'll go through here? EC2, recently visited. Like that. Here we are. Let's go back to instances. I suppose this is what we should be doing. Yeah. In the instances section, choose the checkbox, right? Yeah. Choose the checkbox, select the web server instance. Click the security tab. Under security groups, click the web server security group. Let's see where we go. Inside the security group. On the inbound rules, click edit inbound rules. For each security group, you can add rules that control the traffic based on protocols and port numbers. Separate sets of rules exist for inbound traffic and outbound traffic. Yeah, right. Edit inbound rules. Click add rule. And in the inbound rules section, for type, click the search box to expand the drop-down menu. Scroll down to see the various predefined. Yeah. Review to see that the protocol exists for MySQL, SQL, Aurora. Choose HTTP. Right. You can create a security group and add rules that reflect the role of the instance that is associated with the security group. For example, an instance that is configured as a web server needs security group rules that allow inbound HTTP and HTTP access. Likewise, the database instance needs rules that allow access for the type of database, such as access over port 3306 for MySQL. That's a hint, I think, for DIY. Right. So we have to select HTTP. Right. Then for source from the drop-down menu, choose anywhere IP version 4. Click Save Rules. Security groups are stateful. For example, if you send a request from an instance, the response traffic for that request is allowed to reach the instance regardless of the inbound security group rules. Responses, responses to allowed inbound traffic are allowed to leave the instance regardless of the outbound rules. Okay, so click on anywhere, IP version 4. And save. Okay, inbound security group rules successfully modified on security group. Okay. In the left navigation pane, click instances. Right, In the instances section, choose the checkbox to select the web server instance. Choose networking, and then suppose this will test connectivity using a Java application. Click the networking tab. And click the copy icon to copy the provided address. And open it in a new tab, maybe, in a new browser tab. Paste the instance IP address that you just copied and press enter. Review the application that loads from public IP version, public IP address. Review the connection from the internet to the web server. Right. So the web server is up and it's trying to access database. TCP 3306 allow. Can connect to my MySQL server on 10.10.10.10.10.2 3306. Should be 10 here. Anyway, review the connection from the internet to the web server. The connection should be established. Okay, which it is. Review the connection from the web server to the database server. Connection from the web server to the database server should display as failed. To display working internet gateway, the following must be completed. The internet gateway must be attached to a VPC. Route table associated with your public subnet must have a route to your internet gateway. Security groups associated with your VPC must allow traffic from the internet. Security groups. Complete the practice section, go to the DIY section, complete the solution. Change security group rules to allow traffic over port 3306 into the database server. Our service will determine if the web server can connect to the database server on the port 3306 with custom source subnet 24. Update the security group rules and then review the Java application for a visual confirmation of an established connection status to change connected. The web server using security group web server security group needs to connect to the database server using security group database server security group over a TCP connection on port 3306. Let's try. What did we do earlier? Subnet. Route table. Internet gateway. Wait a minute. Subnet. Route table. There we Right, roots. Uh-huh. Let's go to the database server, networking, subnet, and then root table. Roots, edit. Let's remove that, and then it says 10.10.0.0. So that's 24. That's TCP. Oh, sorry. Target. Aurora, right? Target. Phone save it on private gateway. Not local. Wait a minute. We'll go back a bit. $780. Right. Root table. Click on the root table. Click on the root table. And then roots, correct? Edit roots. Right. So, oh, when you go to the security groups, right. So let's leave that the way it is for the time being. Okay. Security. So security group. On inbound rules, click inbound rules for security group. You can add rules. Protocols and port numbers. Click add rule. Okay. So let's go to the inbound rules, edit inbound rules, add rule, custom TCP, MySQL, J306, custom, I like it. Custom. Ten. Dot 10. Dot 0. Dot 0. Slash 24. Save rules. And let's check now if you go to instances. First of all, if you does it work? Can I connect? Web server. Address. Checking. Can't connect. 10.10.2.10. Let's try and validate it. Ah, wait, that's the instance ID, right? Security group. Right. Let me try the other thing too. Let's go to the web server. Security group. Where's the outbound? Add role. Custom TCP. Where's the logo? No. That's 0/24. And now. If you have any suggestions for that, could you please put them in the comments below? I would really like to play and try and find the visual connection here. Do I need to add a route to the internet? No. Normally not. Wait. Edit. How about I make that an HTTP one? No. By default it becomes that. Web server. Wait a minute. Spot MySQL Aurora. Web server. You may not specify a reference group ID for an existing API version for a CEDAR rule. I mean, database server. Let's go with that. Okay. Maybe now, hopefully. So inbound, that. Come on. Well, as long as it's working. Thanks for solving our networking issues. This is such an elegant solution. The bank is funding construction of the new city hall building. Help us choose the new design. What's with the Warcraft fortress here? Skyscraper? No, let's put a bit of classic with trees. Your player level increased to 6. Your pillar level. Five stars, even though it wasn't because it tricked me. Right, I've seen that the video has become quite big again, so we'll finish part 2 here. And we'll come back next time with part 3, where the next challenges will follow. Have cloud economics, databases in practice, connecting VPCs. That's an interesting one. Right. Up until then, wish you all the best and see you in the next one. And I know I haven't been able to get the connection, so if I do happen to do that, oh, that's a giraffe by the way, because why not? I will make an additional video for that. Until then, have a nice day. Bye.